Hello all, today we are solving LeetCode problem number 3453 separate squares 1. So this is a geometrical problem and this is a medium one. So let us get into the problem. So basically we are given a 2D integer array which is named as squares. So squares of I is equal to x of I, y of I and L of I. So where x of I comma y of I is the coordinates of the bottom left point of the square and L of I is the side length of the square. So consider the 2D grid and this can be the coordinates which is xi, yi, and the length will be and this is the left bottom of the square, right? So the length will be li, which is which makes a square. So all this length will be li, li, li and li, whereas the coordinates will be xi, yi, right? I think this is clear. Yeah, so this is what we are given in the problem. So what exactly is the output which we have to return, right? So we have to find the minimum y coordinate value such that it makes the total area above the square is equal to total area below the square, and return as the float value which has 5 decimal places, right? So you have to be very careful with this because this is one of the constraint given in the problem, right? So what exactly this mean? So we are having one square here, right? So let me expand this. Yeah, so we are having one square here. Sometimes we might have one more above somewhere like this. So we have to draw a line uh, which is horizontal line, which is y equal to something, right? Which will make the area above the y line is area above the y line, that is the area of square equal to area above the area below the y line's square area, right? So this will be equal to this and we have to return the minimum value of the y line which will divide the area into equal area, right? So also before getting into the example, I just want to show the note part, because if there is a possibility of squares to be overlapped, so in case of squares overlapping, overlapped area counts actually, and if it doesn't overlap, it's not a problem. The regular way, like how we calculate by adding up the sum of two squares, that is how we process, right? So now let us jump into the example and understand these two parts, these two note part clearly, right? So first let me get into the first example. So yeah, so let me change the color, and yeah, so now in this example we have two squares, right? So we have 0 0 0 0 as the coordinates here based on this, and 2 2, right? And this is 2 2, and the length is 1 and length is 1, which is what exactly they have drawn here. So now we have to find the minimum horizontal line which separates that, right? So from this we can say that we can draw a line something like this, which is y is equal to 2, and here they have drawn y is equal to 1, and there are so many lines we can draw with the decimal value, because in the constraint they have mentioned up to 5 decimal places are allowed, right? So among all the possible lines, what is the minimum line, minimum value of the line which we can form, which is y is equal to 1. So because of that we are returning the output as 1, right? So this is case 1, and the next case is the overlapped case. So here you have two squares again, which is 0 0 index and coordinates, and 1 1 coordinates. So 0 0 and 1 and 1 1, right? Yeah. So now if you clearly see here, you have the area, the whole area, which is 2 cross 2, which is 4 for the bigger square, and this area is 1, the smaller square. So how does the total area changes? The total area will be sum of these two, because overlapped area counts, that is what they have mentioned here, right? So now you have to find a line in such a way that the area above this line equals to the area below this line. So by this area, this includes this particular square along with this complete square. Sorry, this is rectangle. So this two combines to form a area, and again this complete one along with this particular small rectangle, these two combines to form the area, right? So this is the total problem. So how do we solve this, right? So let me change the color quickly. Yeah. And so based on this, we can say that for any height h, right? So for any height, how can we compute the area above this is y is equal to h, right? So area above the line, area, and area below the line, how do we compute, right? So we can say that also we can say that these two combines to form the total area, right? So let us represent total area as t is equal to area 1 plus area 2, right? And how this y is equal to h is formed. So let us, we can have this as a function. So function of h is formed in such a way that this is equal to area below the line, right? Or we can have it as area above the line. But among these two, or we can, this can be or t divided by 2, because total area divided by 2, because in top of the line and bottom, I mean below the line, the areas are same, right? So based on this, we are defining this function, right? And this above the line, this will not be possible because of the limit, right? So if the bottom we are having the y coordinate, and we can use the length to find the top limit, so that we can substitute and find the area, right? So because of that reason, this cannot be possible. Better I can strike this off. So based on this, we can come to a conclusion that we have to find area below the line, right? And this f of h is equal to t by 2. So if h increases, we can say that the area below increases, right? So based on that, we can say that this is increasing monotonically. So how do we find this line, right? So we can use binary search, because this is increasing monotonically. So binary search. So this is the approach which we are following to solve this problem. So for binary search, we need the limit, right? Uh, the range basically. So let me explain this. The way or the algorithmic way or approach, or how do we solve this problem basically. So how first we have to find the range. So how do we find the range? So you find all the y coordinates value or yi value, and you have it as y val list. You have y1 and y2. So this will be the bottom. So right, so low will be is equal to minimum of all this, minimum of y val, right? So you are getting the value low. And similarly for the topmost, right? So you have you will be adding with the L, because you are given the length of the sides. So the topmost value will be yi plus li value, right? So this will be top is equal to yi plus y1 plus l1 plus y2 plus l2, right? So among this should be maximum, right? So top is equal to max of this top v array, right? So you get the limit. Now you have to, what you have to do is you have to find the area below. Now you have to have a separate function to find area below. Y is equal to h, basically area below h. So there are three possibilities for this, right? So if you're drawing a line, h, y is equal to h, so what are the possibilities that can happen? So the squares can be below this, right? So in this case you cannot, oops, this is below, right? So in this case, if the square is on top of this, the line is bottom, right? So you cannot, there is no area here, there is nothing here, right? So you cannot do anything. So you have to just move to the next iteration, or next what to say, what exactly, next area, or the next iteration to process, right? And in case of if area is below, so now you can calculate the area of square, because of the height is here, and now you can calculate the area, right? And this we can use L cross L to find the area, right? So if this is there, you can find the area below the line, and after that you can equate with area above the line for the binary search operation, right? Because you need area below the line to go with the binary search, right? So the third case is if there is a line is on top of the square. So here what happens is you have square, right? So this will be L and this will be L. So this is a square basically, and y is equal to h, right? So what happened here is you have a line on top of the square, right? So what happens is this become a rectangle. So now you have to find the area of rectangle. So one side is L, because already you have one bigger side as L, because square got reduced to rectangle, right? So the next one will be h minus y, right? So by using this you find the area, and then you make this as the area below the line, and then you just compare, right? So now you perform the binary search operation. So in binary search, what exactly you do is if 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 the area of h is less than target, so here target will be total area by 2, right? if this is the case, then you do what you do is you will make the low pointer to mid, because the area is so less, right? And else the high pointer becomes mid, right? And then at last you will return the h I or h high high, right? Why? Oops. Return high. Why? Because uh, we need to return the answer such a way that area should not be less than, right, less than the target, right? So area of h should be greater than or equal to, or this should be almost equal to. So this is the exact one, but here in this case we are processing by greater than or equal to target. So because of that we are returning the high point, or the high value, right? So now we have the observation, that is first find the range area function. This you have to define, and the binary search. Actually this come first and then binary search. Inside binary search, this area function is nested within it. So because of that we have to define this area function before proceeding to binary search, right? So the time complexity here will be order of big O of n, because we will be for binary search you will be doing and there is you will be performing linear operation for some and then what else you have, finding range, right? And binary search, so it will take almost order of n for this. And also here we will be iterating the binary search for 70 times, because I will be explaining that while coding, and space complexity, this will be space complexity, this is time complexity, and space complexity will be big O of 1. And let me explain this now, right? So binary search, this will be 70 because in the constraint it is given the decimal will be up to 10 power 5, right? So if in binary search the convergence can lose the bits actually, so the decimal bits beyond due to the rounding effect actually. So in binary search the decimal points, the places can be, we can lose it because of the rounding. So because of that we are iterating till uh, 70 times to make sure that the precision is beyond 10 power 12, because that is what given in the constraint. So make sure that the precision is beyond 10 power 12, right? So let us go into the coding part, right? So first we need to find the range. So let the range be low and high. So this will be minimum of y for x, y, and L in range, sorry, in squares. This should be because we are fetching the elements, right? So squares, and here this should be max, and y plus L for x, y, and L in squares, right? And now you have to find the total sum. So total is equal to sum of this should be it is L cross L, right? So L cross L for x, y, and L in squares, right? So target is equal to total by 2, right? So this is done. Now you have to have the area below function defined. So def this should be h, right? And now let us go into this binary tree part, right? So for binary tree, sorry, binary search, my bad. So as I said, we have to iterate till for 70 times. So for I, so we have to find mid is equal to the given is low plus high divided by 2, and now if area, what is the name? Oh, it's area. If area below mid is less than target, you should update the low is equal to mid, else high is equal to mid, because this is greater than or equal to, which is what exactly we want. So now return high. And now coming to this area below calculation, we have the 3 specific conditions, right? So first we need to have a variable. So area is equal to 0, and now for L in range, this is to calculate the area in squares. So you know that that the topmost or the high most value, right? So high is equal, or top is equal to y plus L, and now if h is less than or equal to y, so that is what the first case, right? So here you should not do, you have to go to the next square, the next index in the square, right? So continue, and this is 1, LF h is greater than or equal to y. So in this case, no, this should be y plus 1, right? Because that is the topmost limit, right? So I think this should be y plus 1. There is no need for top, but anyway, top, then here area plus or equal to, we are adding up the area, right? We have to have the total sum, so L cross L, and L's part we know that plus or equal to h minus y, and this will be the rectangular area, right? So now you have to return the area, which will be used for the binary search, right? So let us go ahead and submit this. Yeah, and there you go. Thank you.